Oh, hello. It's Mr. Veve here. You caught me doing some kitchen work. Welcome to Factors Affecting Solubility. So what we're going to talk about right now is how we can get a solute to dissolve in a solvent to make a solution quicker. So I've got here some powder that I want to dissolve in some water. Now, how can I get this done? Well, certainly I could pour the powder into the water and just wait for nature to take its course. But that's a bit too slow for me. See, I'm a fast-paced guy. One thing I can do is I look at the size of the particles of my powder. These could be smaller. So let's actually change the surface area of these particles. I run a very clean kitchen, as you can see. Let's see, if I make the particles smaller by smashing them to pieces, I have decreased the surface area, or increased the surface area that the reaction can take place on. So, smaller particle size equals increased surface area, which means faster dissolving. Still not fast enough for me though. Let's see. You know, I could put my newly pounded powder into this container here, put my water in. Well, it doesn't seem like making the powder smaller did much of anything for me. But if I added this blender ball and were to agitate the solution, that seems to make it dissolve a little faster. But you know what? That will only make it dissolve a little faster. I could change one more factor here to really increase the speed. First things first though, I should take out the metal blender ball. I could put this entire thing into the microwave. Won't you join me? That seems like long enough. All seems to be dissolved. Delicious.
Well, thank you for that entertaining demonstration about factors affecting dissolving rate.
You're very welcome, obviously.
Okay, so we talked about how to get a solid to dissolve in a liquid. Same thing for liquid dissolving in a liquid, same factors. But we didn't talk about gases. So if we talk about gases...
Wait, can gases dissolve in something?
Have you ever had a soda?
You mean like this one?
Yes, like that one.
Huh.
So a gas is, there's two factors that affect the dissolving rate or the solubility of a gas in a liquid. So
Right.
What happens if you put that soda outside or in a garage?
Like a hot garage?
Yeah, a really hot garage. So that would mean temperature is going up.
Okay, well, if I put this out in the garage when it's really, really hot in the summertime, I've done this before because I've left something out there, the can gets like all bulged right here, so like the can just kind of gets all warped and bigger.
So what's happening? Why is the can getting bigger?
Well, it seems like the gas that is in here is trying to get out.
Right, so the gas is leaving the liquid and just filling the space in the can.
Yeah, okay, so if the temperature goes up, the solubility of the gas goes down.
Exactly.
It's not going to dissolve as quickly.
Exactly. Okay, so if you think about that, you get stuck on that. Just think about what happens to a soda. Now, what else do we do?
I don't want you to see that I'm drinking Coca-Cola. I mean, I'm not drinking, I'm drinking a soda.
So, how do we package sodas? How do we get all that gas into the liquid?
How? Well,
How do
we
you
have to.
What happens when you open it?
When I open it, it's pressurized.
Mm-hmm.
So when you open it, you get that really satisfying sound.
Yeah.
Because you're releasing that pressure.
So as pressure goes up, the
Solubility
solubility goes up. So the best soda is lots of pressure low temperature.
So if I open this soda, release that pressure, and just leave it for a long period of time, it eventually goes flat because there's no more bubbles.
Yep.
This makes so much sense now. Thank you.
Okay, so let's recap. So we just talked about gases. We talked about solids and liquids.
Solids, liquids, and gases.
So let's talk about temperature and let's talk about pressure. Let's just recap. Solid, liquid, gas.
Okay, so
as temperature goes up, what happens to dissolving rate of a solid?
it goes up.
Okay, what about a liquid?
A liquid goes up too, same as solid.
Now gas
Goes down.
Okay, good. Remember the hot garage.
Right.
Okay, does pressure really affect solids and liquids?
No, because solid liquids can't be compressed.
So let's just make a line here. It doesn't really affect.
No effect whatsoever.
Okay, what about gas?
If pressure goes up, the gas solubility goes up as well.
Yep. So there's the chart that you need to remember. Also remember to get a solid into solution or into a liquid. We also looked at agitation or stirring, shaking it up, so to agitate something. And what was the other thing you did?
We did surface area. We increased the surface area by decreasing the particle size.
So increased surface area, decreased size.
Right. So we have to make the particles into really, really, really small particles in order to increase the surface area so that it happens faster.
That sounds good.
Okay. That's it.
I think so.
Awesome.